In this video, we're once again going to be taking a bunch of different samples from a population. So we're going to get a bunch of different random groups of people. However, instead of calculating the average, or whatever it may be, average height, weight, and so on, instead we're going to say how many satisfy this condition. So we're going to say what percentage of our sample were Republican, what percentage of our sample are Democrat, what percentage of our sample like action movies. Whatever thing it is we're trying to decide, we're breaking it up into, yes or no, and we're saying how many successes. So we're essentially doing like a binomial variable here, and we're trying to see what proportion. So we calculate the sample proportion, and we use the symbol P hat, and that's going to be the number of successes, whatever that may mean in the context of the problem, over the sample size. And that's what we're going to calculate for each of our samples. So in the previous video, we took a whole bunch of samples, and each one we calculated the sample mean, the x bar, and then we said, what could we say about x bar? And it turned out to be a random variable, and then the x bar turned out to be a normal random variable, and we knew what the mean and standard deviation were, and so on. Same concept here. When we take our sample proportion, P hat will be a random variable. And continuing on, we'd like to know what the mean and standard deviation of this new random variable is. Well, the mean of the random variable P hat, so if you take all the different possible samples you can take, and you take the proportion of successes for each one of those possible samples, and you average that all out, what you're going to get is exactly the same as the population proportion P. So let's say that 60% of the population likes action movies. Well, if you take one sample, maybe that one sample, 70% like action movies. And if you take a different sample, maybe 50% of that sample likes action movies. But if you were to do this for all the different possible samples, and if you were to average out all the answers you get, what you're going to get is the same 60% that is the population percentage you get. So this is telling you that on average, your sample proportion is the same as your population proportion. However, the standard deviation of P hat's a little bit more complicated. The formula we can work out is the following here: the square root P times 1 minus P over N. This is what's going to happen when you're trying to take the standard deviation of all the different P hats you're going to possibly get. However, once again, in order to calculate probabilities, we're going to convert things into a normal distribution. And when is that going to work? Well, if N times P times 1 minus P is at least 10, then P hat will be approximately normally distributed. So what that means is as long as N times P times 1 minus P is the number at least 10, then we are good to go to use our normal CDF in our calculator to calculate probabilities. On the other hand, if N times P times 1 minus P is not at least 10, then we don't really know what to do. So you can expect when I ask you these questions that it is going to be at least 10. And so let's do a quick example of how to take all this knowledge and calculate a probability here. So we know that the population has 55% that are in favor of some new law that they're trying to pass, this new bill. And we're going to randomly select 100 people from our population. And I want to find out what's the chance that in the 100 people I randomly sample, that less than half of them are going to want to vote for this new bill. Right? And that would be something concerning, right? If you want the bill to pass and you take a sample, and in that sample less than half would vote for it, well, that means maybe you should be worried about whether your bill is going to pass or not. So this is something that a person that is trying to get a law passed would absolutely care about, this type of problem here. So we have our P is 0.55. That's the population percentage, population proportion. We need to check whether n times P times 1 minus P is at least 10. If it's not, then we really can't do anything at this point. So my n here was 100. My P is 0.45. My 1 minus P is 0.45. And so I type this in my calculator really quickly here. And I get 24.75. That is definitely at least 10. So that means we're good to go in using our normal approximation. But before I can do that, I need to know what the mean and standard deviation are. Well, the mean of P hat is just the same as the population percentage. And the standard deviation of P hat is the formula right above here, P times 1 minus P over n inside a square root. So we have 0.55 times 0.45 over 100 square root. Now we got to put this in my calculator. So 0.55 times 0.45 divided by 100 and square root. And I'm getting a 0.0497. I could have rounded that to 0.050, but I left it that way. So now I have my mean and I have my standard deviation. And I'm trying to find the probability that P hat is less than 0.5. So I'm going to go ahead and put this into our TI calculator to get our answer. So I'll pull that up here. So second vars. Down to normal CDF again, because we're doing here. We want to be less than 0.5, so negative infinity is good, up to 0.5. My mean is 0.55, and my standard deviation was 0.0497. Type all that in there, hit enter, enter, and I get 0.1572 it looks like, 0.1572, or 15.72%, or maybe 16% if you want to round it a little bit more. So what this means is that even if 55% of your population agrees with passing some new law, there's still almost a 16% chance that if you survey 100 people, that among those 100 people, the bill would not pass. And I want to point out here, this is something really beyond this class to realize, that even when a majority of the people in the whole population are okay or would prefer a new law to pass, you can think of taking your sample as the people who choose to vote. And like in this case here, there's a decent chance that the outcome of the vote does not match what the population would actually choose. This is why it is important for everyone to vote, so that we can get the information of what everyone actually wishes, so that we can decide which laws should pass and which laws should not pass. When you only allow, half the people or less than that actually voting, you're missing out on a lot of people's desires, a lot of people's wishes, and the laws that pass are not necessarily going to be representative of what the population as a whole wants to actually succeed. So everyone, get out there and vote, make your voice heard, so that we can have more accurate laws based on what the population actually wants.